When the first images arrived from the Perseverance rover, no one understood what they were seeing. The rover wasn't even supposed to be looking for anything connected to 3I-ATLAS. It was carrying out routine scans of the Martian horizon. Dust levels, cloud movement, geological shifts, nothing unusual. But then, in the corner of a long exposure frame, something appeared. Something that shouldn't have been there. A faint streak of reflected light arcing across the sky, too steady to be a dust devil, too bright to be a satellite, too linear to be noise. Engineers thought it was an artifact, a lens glitch. But the second image came through, and the streak wasn't gone. It was sharper. That was when the atmosphere inside NASA shifted. The rover had captured something moving behind the Martian haze, something that aligned perfectly with the projected sky path of 3I-ATLAS. At that exact moment, Mars shouldn't have seen it. Not from that angle, not with that clarity. But the reflection was real, and it was rising from a point just above the western horizon, catching the last light of the sun in a way that made no sense. Rover imaging software flagged it as non-atmospheric motion. That classification is only triggered when something moves in a straight path with an angular velocity too slow for meteors, too smooth for drones, and too high to be ground reflections. Whatever was up there wasn't drifting, it was gliding. Within minutes, NASA cross-checked the timestamp with data from the Mars Reconnaissance Orbiter. The orbiter had also recorded a faint thermal spike, almost nothing, barely above background noise, but it came from the same direction Perseverance was looking. A spike like that shouldn't exist unless something with mass and reflectivity passed through the thin upper atmosphere. Not close enough to burn, just close enough to be noticed. That was the moment scientists stopped calling the rover's image a glitch. Something had moved above Mars, and it wasn't debris, it wasn't a satellite, and it certainly wasn't a comet tail. Back on Earth, the Virtual Telescope project tried to reproduce the observation from orbit. They expected a dim smear, maybe a dust plume. Instead, the new composite showed something narrow and elongated. Too narrow to be a natural coma, too defined to be dust scattering a structure. Not a solid object, not a spacecraft, but a shape in the light itself. Almost like a shadow made of brightness, stretching behind 3I-ATLAS, in a way no natural object should produce. And then, Perseverance captured something even stranger. A second glint. Not from the object, this time from the ground. Instruments picked up a tiny localized reflection bouncing off the regolith near the rover's position. Mars has no mirrors, no metal debris, no polished surfaces. Nothing should have reflected sunlight that sharply, especially with the sun at that angle, but the reflection synced perfectly with the brightness pulse coming from Atlas. Mars wasn't just seeing the object, it was responding to it. Dust levels surged, electrostatic charge increased. Even the thin Martian atmosphere, normally so quiet, started behaving like a vibrating shell. Tiny ripples moved through it, invisible to human eyes, but clear in the rover's pressure sensors. The atmosphere wasn't reacting to winds, it was reacting to the pulse from the sky. Then came the biggest shock of all. The Mars Odyssey orbiter recorded a sudden dip in cosmic ray counts. A drop like that means one thing. Something was blocking radiation. Something big. Something with mass or field density strong enough to shield the orbiter from cosmic particles. For a few seconds, when analysts plotted the dip, it lined up with Atlas's trajectory. It was impossible. A comet cannot block cosmic rays. Dust cannot. Ice cannot. Only magnetic fields or engineered structures can. Even with all of that evidence, NASA stayed quiet, but the silence didn't stop the data. The next rover transmission revealed a thin, faint vertical streak in the sky, one so sharp that it looked almost drawn across the frame. Not random, not curved by wind, a straight, consistent line of brightness, almost like a beam. When multiple frames were stacked together, that line kept reappearing in the exact same position relative to Atlas. Something up there was holding formation. As Earth rotated into view later that night, the Mars sky darkened, but Atlas didn't vanish. It dimmed just enough to blend with the stars, then flared again, briefly but deliberately, as if calibrating itself. And that flare was picked up by the Indian Deep Space Network, then by ESA's tracking array, and then by amateur astronomers halfway around the world. For the first time in this entire story, Earth and Mars saw the same flash at the same moment. two planets detecting the same object together that shouldn't be possible. The timing alone requires precision beyond anything natural, but the synchronization was perfect. It was almost communicative. A chill ran through the scientific community. What if the Mars rover didn't just catch a glimpse of ATLAS? What if ATLAS positioned itself to be seen? For decades, astronomers have known that light can be encoded, that reflections can carry patterns, that solar glints can convey information, but nothing ever glinted like this. The Mars images showed something steady, deliberate, almost patient, a line of brightness that tracked with ATLAS's rotation, not the sun's angle, a reflection that behaved like a response, like an acknowledgement. And as Perseverance continued snapping photos, the images revealed one more detail, the most disturbing of them all. ATLAS wasn't moving away from Mars. It was slowly adjusting its trajectory back toward the ecliptic, the plane of Mars, Earth, and the Sun, a motion so slight it would take a supercomputer to detect. Yet it was there. A gentle arc, a quiet correction, a shift toward alignment. This wasn't a comet drifting through our neighborhood. This was something navigating through it, and whatever glanced back at Mars, whatever sent that reflection into Perseverance's camera, wasn't an accident. It felt intentional. The moment scientists tried to dismiss the rover images as coincidence, the data from Mars began proving them wrong. Hour after hour, new readings came in, each stranger than the last. The Martian sky wasn't settling down after the reflection. It was becoming more active. The thin atmosphere, usually still and predictable, started showing faint vibrational shifts. Pressure sensors detected micropulses that matched the exact interval of ATLAS's flashes. When the object brightened, the Martian air trembled. When it dimmed, the atmosphere fell still again. It was as if Mars itself was reacting to a signal coming from deep space. But the strangest part wasn't the atmosphere, it was the dust. Martian dust normally moves in chaotic spirals, shaped by weak winds and temperature gradients, but now tiny plumes were rising straight upward as if pulled by a force that didn't exist on Mars. Under normal physics, dust can't behave like that, not without magnetism, not without electrical charge, not without something interacting with the environment from above, something that wasn't supposed to be there. Engineers ran the numbers again and again. The dust plumes climbed exactly when the brightness peaks from ATLAS hit the rover's position. Each plume followed the same height curve, starting fast, rising, then pausing mid-air before dropping back down. That pause was impossible. Dust doesn't stop mid-climb. It rises or falls, but these plumes held themselves still as if suspended by an invisible hand. Then came the audio data. Perseverance's low-frequency microphone picked up a faint rumble. Too quiet for humans to hear, too rhythmic to be wind. When analyzed, the waveform matched the same repeating interval found in the object's light pulse. Scientists tried to explain it away as rover vibration, but the sound was coming from the atmosphere, not the rover chassis. Whatever ATLAS was doing out there in deep space, the echo of it was now reaching Mars like a distant heartbeat. Meanwhile, the Mars Reconnaissance Orbiter captured something no one expected. Using its night-side infrared imager, it saw a long, faint trail stretching behind ATLAS, far longer than any cometary tail should be at that distance, but it wasn't glowing like gas. It was cold. A cold tail in infrared means one thing. The structure wasn't material. It was a shadow made not of darkness, but of absence, as if ATLAS were bending radiation instead of emitting it. And that shadow wasn't random. It was straight, too straight. When enhanced, it showed a geometry almost never seen in natural objects, a line that didn't curve with solar pressure or gravitational bending. It held shape like a beam. Back on Earth, the Virtual Telescope Project reprocessed their high-resolution frames. They expected noise, maybe stray light from Mars, but after removing atmospheric interference, the tail sharpened into a thin, nearly perfect band, a band that flickered with the same pattern as the pulses ATLAS had been sending for weeks. Light normally scatters chaotically, off a comet, but this band was behaving like a conduit, oscillating in harmony with the object that created it. That was when researchers noticed something chilling when they aligned all the images from Mars, from orbit, from Earth. They discovered that the band wasn't pointing away from the sun the way a comet's tail should. It was pointing toward the sun, reversed, as if ATLAS wasn't shedding material. It was absorbing something. Then James Webb stepped in again, providing data that shut down every natural explanation left. When Webb scanned the object's polarization profile, the pattern revealed something impossible. Polarization is the direction in which light waves vibrate. Natural objects produce random polarization. But ATLAS's pattern was structured. Every pulse realigned the polarization at a perfect angle, 47 degrees, then shifted exactly 8 degrees lower, then reset over and over. Never drifting, never slipping. This wasn't physics. This was formatting, light being modulated deliberately as if encoding information. Some said it looked like a beacon. Others said it resembled handshake protocols used in deep space communication. No one wanted to say the word, but everyone was thinking its signal. And Mars wasn't just observing the signal anymore. It was being touched by it. Perseverance's radiation detector, which usually shows a smooth curve of cosmic rays, suddenly recorded a dip, a brief moment where radiation dropped before rising again. That shift lined up exactly with the brightest ATLAS pulse of the week. Cosmic rays don't drop like that. They're constant. They don't react to light from a distant interstellar object, but something had shielded the rover for precisely one pulse, like an invisible wave had passed between ATLAS and the Martian surface. Even stranger, the same phenomenon was detected by the orbiter's MRO, Odyssey, MAVEN. Each one recorded a synchronized drop in radiation exposure for a fraction of a second. All three satellites, in different orbital paths, experienced the same dip at the same moment. Whatever passed by wasn't atmosphere. It wasn't solar activity. It wasn't coincidence. It was directed. Scientists in mission control sat in silence as the data streamed in. This object, this thing, was influencing an entire planet from millions of kilometers away. It had no engine, no antenna, no visible structure. Yet, it emitted pulses that traveled across the solar system and physically interacted with Mars. And then, the final piece fell into place. When analysts overlaid the radiation dips, the dust plumes, the atmospheric tremors, and the light pulses, the timing formed a single, unified pattern. Every effect on Mars was synchronized with ATLAS's emission. Not delayed, not distorted, perfectly aligned. Whatever ATLAS was doing, Mars was part of it now, and as the rover continued taking images, the reflections grew sharper. The streak in the sky became more defined. And for the first time, the pattern wasn't random. The streak was angled precisely toward a point in space, toward a future orbital location Mars had not yet reached, a trajectory, a path, a meeting point. This wasn't a comet reacting to sunlight. This was something positioning itself, something waiting. And Mars had just shown the world the first sign that 3I-ATLAS wasn't observing the solar system from a distance anymore. It was interacting with it. In the days after Mars revealed the first signs of interaction, something even stranger began happening. The pulse from 3I-ATLAS, once faint and distant, started appearing in places no one expected. Earth's deep space network picked up the same rhythmic tremor Perseverance had detected, matching it down to the millisecond. At first, engineers thought it was bleed-through from Mars transmissions, but when every antenna in California, Spain, and Australia registered the pulse simultaneously, the truth was impossible to ignore. The signal wasn't coming from Mars. It was washing across the solar system like a tide. And then Earth reacted. High-altitude magnetometers began recording microscopic oscillations, tiny shifts in the planet's magnetic field that matched the same frequency ATLAS had been emitting for weeks. These weren't dangerous spikes or storms. They were gentle pulses, barely above background noise. But they were consistent, repeating every time ATLAS flashed. Mars reacted first. Earth was reacting second. And whatever this object was doing, it was reaching farther than anyone imagined. Meanwhile, new images from the Mars Reconnaissance Orbiter came through. Images that analysts stared at in silence. The faint elongation behind ATLAS wasn't shrinking as the object moved farther from the sun. It was expanding. Slowly, steadily, symmetrically expanding. The shape was no longer a thin line. It had begun forming a faint spiral, a barely visible curvature that shouldn't exist around anything natural. Light doesn't curve on its own. Not like that. Not with such structured precision. researchers enhanced the frame again and again, expecting noise, distortion, artifact. But every version revealed the same strange architecture, curvature, repeating arcs, almost like a helix of faint luminosity radiating from the object. It looked less like a comet tail and more like a field changing shape. No one understood why, not yet, but the feeling spreading through mission teams was the same. Whatever exploded near the sun did not break Atlas. It changed it. Then the Mars rover recorded something it was never meant to detect. The seismic experiment for interior structure, a tool meant to read vibrations through the ground, captured a low-frequency tremor. It didn't come from below the surface. It came from above, from the sky, a vibration passing through the thin Martian air and into the soil. And like everything else, it matched the pulse. That was the moment scientists realized the object wasn't just reacting with light. It was interacting with matter, with radiation, with magnetism, with gravity. Every domain of physics had begun echoing the same rhythm, and all of it originated from something drifting silently between planets. Around this time, ESA analysts released something quietly to internal teams, a 3D reconstruction generated from all available images. It showed the faint spiral behind Atlas not as a tail, but as a three-lobed formation, 3 arcs, 3 repeating angles, a trisymmetry no comet has ever displayed, but which appears in one particular place in astronomy, the WOW signal region. That realization struck like lightning. The 1977 WOW signal, a lone, unexplained 72-second signal recorded from deep space. It came from a precise region near the constellation Sagittarius. Astronomers had spent decades trying to decode it, searching for anything that matched its shape or frequency. Now, for the first time in nearly half a century, a pattern similar to that signal had appeared. Not in radio waves, but in the geometry surrounding 3I-ATLAS. No one in NASA could say it aloud, but they all understood the implication. If this was coincidence, it was the most elaborate coincidence in cosmic history. As Atlas drifted toward the outer regions of Mars's orbital path, its pulses became more stable. The rotation of the object synced perfectly with the emission, forming one seamless rhythm. Light, rotation, magnetic echo, everything in perfect alignment. Then something even more unsettling happened. During one of Atlas's pulses, the Mars rover's onboard computer executed a micro-reset A reboot lasting less than a quarter of a second. Deep inside mission logs, an error code appeared that the rover had never produced before. It referenced unexpected high-frequency carrier, as though something had passed through the rover's communication hardware, a pulse strong enough to momentarily disrupt its systems. The rover rebooted normally. But the timing was exact. The pulse from Atlas hit, the rover reset. Delay, 0. NASA classified the event instantly. And then, without warning, Earth's deep space network suffered a similar glitch. During the strongest pulse of the week, a handful of ground antennas momentarily froze. Not all. Just a few, those oriented toward the region of space where Atlas had last been seen. The antennas came back online seconds later with no damage, but one file appeared in the logs, data that no one requested, no one sent, and no one could explain. A packet of binary, short, repeating 6 bits long. The same 6 bits sent 247 times. No one knew what it meant, but it didn't look random. Out in space, Gaia, the ultra-sensitive European observatory, picked up something new. Not light, not radio. A faint disturbance in stellar parallax readings, as if something had passed in front of distant stars for a fraction of a second. Something small, moving fast, leaving a distortion like a pebble thrown through the fabric of the sky. Gaia's data team tried to triangulate it. When they plotted the path, it intersected with the orbital plane of Mars, and then angled downward toward the inner solar system. Toward Earth, NASA did not comment. No one did, but leaks began flowing. Small pieces of information from analysts who knew what they were looking at, but couldn't say publicly what they feared Atlas wasn't drifting away. It was returning. The object wasn't finished, and whatever Mars captured wasn't just a reflection. It was a message. A final image from the Mars Reconnaissance Orbiter confirmed the fear. The expanding spiral behind Atlas was no longer faint. it had developed a darker core, a deeper trough of distortion running down its center, like a tunnel forming in space itself, faint but undeniable. Something was unfolding. Mission logs referred to it as a spatial resonance anomaly. Others called it a corridor. A few, whispering late at night, called it exactly what it looked like: a direction. The signal hasn't stopped. The pulse hasn't wavered. Every 247 seconds, the solar system hums. Mars feels it. Earth feels it. Even the void between planets seems to shiver with each flash. Whatever 3I-ATLAS is, it is not a comet. It is not debris. It is not finished. It is preparing, aligning, approaching. And if the patterns are correct, the day the pulse finally stops might not be a warning. It might be an arrival.